Welcome to Interchain FM. You're listening to the Cosmos radio station. I'm your host, Chango Unchained.
I'm Ozymandias, and come to you live from the Cosmos.
Very nice. So, Ozzy, why are you here, and what are you building on?
Well, somehow the forces of the universe brought me to this location with this fine astronaut, and I'm building a messaging protocol, not consensus messages. I'd like to clarify that because IBC is already working on that, but primarily social. So it's essentially a decentralized messenger for open communication. You can think of it as a decentralized version of Telegram or Discord.
Decentralized social is quickly becoming a new narrative, the way ICOs were in 2017 and the way NFTs and DeFi were in 2021. I suspect that in the upcoming bull cycle, this is going to be a narrative, the way that Metaverse has a footing in the ground. So why are you building this? Why is it important?
Yeah, so I think if you just take a step back, sort of the internet and its evolution as a whole, you can see sort of a trend forming with both first authentication layers and messaging layers. So Web 1, say 1990 to 2005, email was the primary authentication layer, Gmail was the primary messenger, and the protocol used was SMTP. And that was the first iteration of using communication networks online for large audiences. And then Web 2 was phone number. That was the authentication layer. SMS was the protocol. And you saw WhatsApp, Signal, and all these other messengers come to life. And interesting enough, the phone number, the authentication layer was client-side. So multiple actors could plug into the social graph of the phone number. And now, as we went to Web 3, essentially wallets are the next authentication layer. And my goal is to build a wallet-to-wallet messenger. And if you sort of look at social coordination and some of the recent phenomenons, I would say the most recent tooling for enabling mass coordination was the group chat. It coordinated multiple random actors into a specific chamber to allow for communications. And essentially with the next evolution of the internet, we're now going into essentially what they call the ownership economy. And I think if you look at sort of some of the biggest issues plaguing sort of society, freedom of expression, freedom of speech, and self-expression are sort of cornerstones to freedom. And it would be inevitable, essentially, that a social coordination tool like blockchains would also enable freedom of expression. So I think that's sort of the reasons why I'm working on it. And I can talk more about it, but that's sort of the gist. Right.
And what would you say to people who think Telegram, Twitter, Signal are enough to solve that problem?
Yeah, I would say, first of all, your identity is usually doxed when you enter these platforms. So they don't really respect pseudo-anonymous actors or anonymous actors themselves. So Twitter, Telegram, Signal all ask for your phone number or an email, which can give away identifiers. As we sort of enter this new age of information and you want to enable sort of pseudo-anonymity, and these platforms don't really allow for that. Furthermore, they can censor you. There's active censorship that occurs on all of these platforms. And that censorship usually restricts natural formations within ecosystems, specifically expressions of ideas. So I think those are not sufficient. I think they come close to sufficiency. I'd say Signal comes to the closest, given it allows for encryption. But sort of the world we're headed in, your phone will become so powerful that it can be its own node. So you wouldn't need centralized services to sort of connect to natively.
And what sorts of issues do you see emerging from using your SMS telephone number as your identifier?
I think the main things are there's like a lot of 2FA scams that occur where like people essentially can SIM swap you. And that's caused already a lot of sort of damage to people in the ecosystem. Another thing is like, it's very interesting. The phone number is sort of a very fascinating identifier because the first three numbers are sort of your tribe. 718 is New York City, 305 is Miami, and these signifiers sort of allow you to be identified. And as we sort of enter this cypherpunk age of infinite information and hyperspace and all this, you really don't want identifiers without your consent. So I think inevitably the future will be selective interaction, selective disclosure, and these tooling sort of limit that. Furthermore, like the phone number can be censored by the government. And again, I think on a long-term basis, no one can ever censor information. To me, information is like consciousness. It's ethereal. You can't touch it. And you can't stop it from expressing itself. So I think that's sort of the timeline we're going to head towards.
Yeah, don't you think that using phone numbers for authentication is akin to having horses as your primary vehicle in a world where there's already highways. So we've kind of put the cart before the horse, so to
100%.
speak. With
It's like you're using
cryptocurrency.
CD-ROMs to consume data when we just invented streaming from Netflix. It's an order of magnitude better and more powerful and redundant.
So explain this next generation communication protocol that you are building and tie that back into the blockchain paradigm.
Yeah, so essentially, I'm not starting from scratch. I would not suggest anyone start from scratch when building a messaging protocol, specifically for social. There's a lot of players that have sort of worked on this for quite a while and have done deep research on it. And what I'm using is essentially called the Matrix protocol. In my opinion, Matrix is the closest implementation of a peer-to-peer and a federated model for decentralized communication. Just to give you a general overview of how the protocol works, it's very simple in terms of what it's doing. It's sending JSON objects over HTTPS and using the signal encryption protocol to send it. And all messages are encrypted, client-side and server-side. And furthermore, the messages that you pass are replicated, client-side and server-side. The easiest mental model to use is, think of it as Git. And each player is essentially duplicating their own Git directed acyclical graph DAG across clients. So we're using the Matrix protocol, and Matrix is a federated system. Just to give you some context on what a federated system is, SMTP email is a federated system. So Gmail can message Hotmail, Hotmail can message Yahoo Mail. They're all using the same underlying infrastructure. That's how they're able to connect. Likewise, Matrix has nodes, and these Matrix nodes all speak the same language. Thus, they're able to federate and communicate. And some other fascinating things about sort of Matrix is that they've also built out a peer-to-peer functionality. So you can use lib peer-to-peer from Protocol Labs as a overlay network. You can also use Bluetooth Low Energy and sort of your Wi-Fi receiver to create a localized mesh network. One of the core things that I'm sort of passionate about is, in the event of a crisis, can humans socially coordinate? If there's an earthquake, there's a fire, the telephone lines go down, you have a supercomputer in your hand. Why can't it talk to other supercomputers around you? I think that's one thing that I think I'm really deeply passionate about. And in terms of the blockchain, a lot of people working in Web3 social sort of make this big mistake of assuming everything should be on-chain, which I deeply disagree with. You don't want consensus overhead for all messages. I mean, that's just like, you're just bloating the chain for no reason. Also, like, you don't want that latency that consensus causes. So the only thing we're using on-chain is identity and essentially transactions. Everything else is off-chain, hosted in federated servers. So that's specifically how the blockchain is interacted, and that's how specifically we use Matrix on top.
What would you say to those people that argue that immutability of text messages need to be on-chain for whatever reason? And why to you is identity the only application where blockchains make sense?
Yeah, so in the specific context of social, basically identity you need consensus for. You need economic guarantees of that specific data. So in the event of a essentially sort of a crisis in terms of losing your phone or your anything that your identity is attached to, you still have the immutable ledger as a backup that no one can ever sort of erase, and you can plug in essentially your identity from there into any other system. Sort of the approach some other people taking in terms of on-chain social, that is sort of a worse situation than Cambridge Analytica. If your whole social graph is on-chain, any actor can now see all of your interactions, all of who you interact with, all of what you do, your social graph, everything is public. And I think that's a very grave mistake. I think a lot of people talk about, hey, ZK this, ZK that. As much as that's cool, and I think ZK will be the sort of future of scaling and like privacy, I still believe the mode you should operate with is selective disclosure. All the data is on your phone and on the clients. It should only be accessed with your permission. If all the data is on-chain, everyone has permission to access it.
Right, that makes total sense. So what I'm hearing from you is that the only property of this entire application that needs censorship resistance is on-chain identity, because that is what's important in case there's a state level actor trying to censor you. They're not going to care about whether or not you tweeted about your lunch last Christmas. So that's the part that
100%.
needs censorship resistance. So, okay, tell me this. In this federated client server model, who is hosting the servers?
Yeah. So for the time being, it'll be us. So we'll be hosting the primary servers. And there's a few reasons for that. We don't want to decentralize too early because of we want to have a really strong velocity of implementing the features we want and to build out our network effect. So in the current model, it will be us. In the future, however, we essentially expect our model to allow each device to be its own server. So essentially your phone is its own node. The app installed on your MacBook or your Windows is its own node. And these nodes are essentially replicating your data. So when you send a message to me on your phone, it gets replicated on your computer as well. There's no reason why that shouldn't be the case already. You have a device that's connected to the internet that has massive storage. There's no reason why you need a centralized server to store all this data. So that's the client server model. And yeah, in its current implementation, it will be us managing the servers. Mm-hmm. But as we sort of progressively decentralize, the end state is that the user is the node. The user doesn't even have to consider running a node. Just running the app is the node.
In this application where I need my laptop with your client, so if I needed to synchronize with what I'm messaging on my phone, that's how it would work.
Yes. And also, you would use the federated servers as backup and redundancy. So in the case that your laptop is off or your phone is off, you can use the federated servers would host your data. Or interestingly enough, you can choose your friends to be your nodes. So if your friends' computers are on and they're sort of seeding you, just how like BitTorrent works, you could still use essentially your friend as a relay instead of a federated node.
Okay. Can you just describe how BitTorrent works just to precise context?
BitTorrent essentially sends data in chunks of algorithms, and it's very interesting. It's very similar to how Celestia works as well, where essentially you send twice or three times as much data, and you're randomly sampling that data set, such that the likelihood of recovery of that data is much higher as you take random samplings of that. So say you're sending like 50 megabytes, you're actually sending 150, but you're sampling random amounts of that 150, such that any other participant is holding on to another shard of that data. BitTorrent was probably one of the first to sort of implement this really fascinating model of seeding and sort of this marketplace for data being hosted by peers. I think that was the first implementation that really worked.
For the user, can they opt into end-to-end encryption, or is it end-to-end encrypted by default, or none of the above and it's something else? Yeah.
So for the time being, it's there isn't end-to-end encryption, although we can enable it, and we've chosen not to, primarily because we want to make the app normie friendly. And there's another reason as well. When you log in with your private key, you're already managing a key, but when you use sort of the end-to-end encryption, you're using the Signal protocol for encryption, and I have to give you another key. Until I can match the schema for the wallet encryption to the Signal protocol encryption, managing another key is sort of very bad UX, something that I don't want the user to do. And also given how fast we're in terms of trying to implement features and stuff, for the time being, we have a disabled end-to-end encryption. However, Matrix already comes with sort of encryption out of the box, so we could pretty much easily enable it whenever we wanted to. And we absolutely will.
Yeah, if it's in the roadmap, then that's great news. I imagine that the people who would be your earliest adopters care about privacy.
Absolutely, yeah.
Right. The question would be, if the US government or some government subpoenaed the data on your servers, is there a way for them to access all of that, or is there encryption and they can't actually unlock it?
Yeah, so for our servers currently, they're not encrypted. So if the data subpoenas, they just go into the Amazon warehouses and take the data. Although, given we're pretty small, we don't expect a nation state actor to come at us just yet. Although as we continue to grow and sort of think about decentralization and think about sort of our users and the privacy they expect, we really want to take into consideration these tools, specifically with encryption. And the other thing is that our long-term goal is that you're not using these large federated models. You're using your laptop, your phone, as these mediums of relays, such that they'd have to come to you to get your data. And I think when data is sharded to that degree, it's a very difficult cost, a difficult coordination cost for the government or a nation state actor to try and implement that.
Right. And in terms of other sorts of these applications, do you remember in 2017, Kik and Kin attempted to solve this problem, Status as well, before they pivoted? How is this protocol different?
Yeah, so Kik wasn't really a decentralized model. It was pretty much a centralized implementation of a general pub sub model. Status was very interesting. and I was deeply into Status in 2017. Primarily, the one flaw though with Status is they use something called Waku. Waku is the peer-to-peer communications system for Ethereum nodes, and I think they were sort of ETH maxis, and they just used Ethereum's messaging protocol and tried to build a communication layer on top of that. And there was some very big scalability issues, so they were not really able to scale as effectively with that.
And that preceded CryptoKitties too.
Yeah.
So
and
before they could have anticipated
honestly,
that.
I just think they were just so early. I kind of feel bad. Like they were really early.
Going to the economic side, tokenomics model, is there going to be a token?
Yeah, so there will be a token, but we don't plan on launching a token before product market fit or before we have like 5 to 10 million users.
Wow.
Yeah, so we're pretty focused on creating a product that has product market fit that we can attempt to monetize without needing a token. And then when we see and understand how users are using our protocol, we can understand where tokenomic incentive mechanisms make sense and not just randomly try and shove a token down. I think some of the mistakes that a lot of these Web3 social companies made, like Steemit, I mean, they've all experimented, which we're really grateful for. But having a token too early sort of attracts mercenary individuals and people that sort of attempt to extract rather than sort of operate in its normal use case. And I think our goal is to essentially ensure that as people are interacting on our protocol and our messaging app, we can understand where it makes sense to insert a token to make better coordination possible. And I'll give you one example that I think is very interesting. There's two. There's something called namespace staking, where essentially assume you have an ENS name. To get that name, if you have a zoname, you would stake the native currency just to hold that name. And that allows for a light form of Sybil resistance by having an economic cost to having an identity on that chain that's human readable. You can have a non-human readable name, but that sort of signals to other participants that you might be a bot or a sort of spammer. Another very interesting utility of the token we think about is sort of attempting to kill spam. A lot of these ideas came from Hashcash. So Hashcash was a predecessor to Bitcoin. Bitcoin was deeply inspired by it. Hashcash used email as essentially a messaging layer and tried to stop spam on email using proof of work. So you'd create Hashcash as a proof of work to essentially be able to send emails to stop email spam. And that was a very interesting model. And the way we're thinking about it is, if Django is my friend, I can message her freely. She can message me freely. If she's not my friend and she's a stranger and she tries to message me, I could have a message fee. I'd have to stake X amount of tokens to be able to message her. She'd have to stake X amount of tokens to be able to message me. If I respond, she gets the asset back and the yield back, and we can talk freely. If I label it as spam, I might, we haven't thought about it fully, but we might slash her a little, but the yield she would have gotten that she staked goes to the protocol. So it doesn't go to the user because the user might, there's an incentive for the user to say everything is spam so they get money, but the staked yield goes to the protocol. So now there's an opportunity cost for people attempting to spam. And furthermore, there's a very interesting model that Cypherpunks created called Web of Trust. So if we're friends and one of her friends reaches out to me, they would not likely have to go through this spam mechanism because she's trusted and she's my friend, and her friend I could trust. So those are some interesting models we're looking at. And the final sort of idea of using the token, there's two others where essentially if you're running a large federated node, you would stake the token to ensure you're relaying all the messages appropriately and you're not censoring anyone. And then the final sort of idea we're thinking about is, in the event that you don't have internet access, essentially all the people with nodes, all the people with peer nodes on your phone, when you want to send a message, the cost to send a message is calculated by how much bandwidth is available nearby. So if there's like 100 nodes with people with their phones, the cost to send a message is pretty low. But if there's a very few actors, there's a cost to send a message that's peer-to-peer, just so it's incentivized. Most mesh networks sort of fail because they're disincentivized, and sort of it causes a lot of relay spam. I think an incentivized mesh network would probably do it really well.
That's interesting. So if there were an economic disincentive for people to spam, could this potentially reduce phishing attacks? If we think about the prominent phishing attacks today with cryptocurrency users, we have people sending malicious links to bad websites that get them to log in with their wallets and then drain their accounts. Or we just straight up have people spamming other people to try to get them to redeem a shitty airdrop or what have you. Have you thought of mitigating those types of messages?
I think one other thing I'd mention is specifically for people that are doing on-chain social is you can't stop a write to the blockchain. So if I send her an on-chain message, she can't not accept that. She has to accept that because it's on-chain. And that limits sort of the capabilities of someone from stopping the spam. So sometimes if you just go on your MetaMask wallet, you'll just see like hundreds of random NFTs that you never really asked for, and you have no way of not accepting that. You have to accept it. There's some interesting issues that can arise from that. For example, if I sent on her MetaMask address an NFT of her address, her real physical address, I've sort of doxed her. And there's nothing she can do to sort of, I mean, she could try and burn the NFT or send it to someone else, but that sort of like imprints physical data onto her address. Like you only have write access. So with our messaging system, it's selective disclosure. You get to decide if you want to talk to this person, if they want to send you messages. And I 100% agree that when you have this sort of tokenomic incentive on top, it reduces the likelihood of all these spams from occurring. I just want to kill spam, honestly. Like, it's just so fucking terrible.
So I talk to a lot of people about decentralized social, and this might be hyperbolic, but I haven't heard any one of them talk about preventing spam. So especially for messaging, this is especially prescient because, yeah, it is problematic if people want to append everything permissionlessly onto the blockchain as if block space were not a constraint. And the doxing problem, that's a major issue. So on Ethereum, if you were to use Ethereum as a base layer for this application, it is, and there's no spam prevention mechanism other than gas, it's really bad because appending personal sensitive data, like someone's physical address, is almost free. And so the Ethereum blockchain is pretty much used as if it's IPFS. And so you append someone's address to it immutably without thinking about the negative consequences. That's actually a really naive implementation of a decentralized social app.
Yeah. I think there's a few that are on-chain social, like DSO. There's I think there's Steemit that was on-chain. Arweave's implementation is just for a database, so you can build on-chain social on it, but you don't. Some people are attempting that. I don't know if the economics of that makes sense to have everything. Like, I don't think a normie is going to want to sign every single message.
Yeah, I would agree. I absolutely agree with that. Yeah,
it's a very a lot of people. You have to really think about the UX. I think maybe we're sort of native to it, and we would be able to. But that is a very Lens protocol is another really good example. You have to sign everything, and that's a very bad UX.
Yeah, though Lens protocol. So I just claimed my name on Lens, and they allow you to opt into automatic signing in the back end where the user doesn't actually have to do it. However, I do agree that that mechanism is doesn't necessarily disincentivize spam per se while hurting UX.
100%.
Yeah. So let's talk about the underlying blockchain ecosystem that you are going to use. And from what I understand, that's going to be Celestia, right? And that's how you're involved in Cosmos. Yeah.
So we've really explored sort of a lot of the chains that we want, that we think would be a good fit. And Celestia sort of, there's a few others, but Celestia is sort of the main one we're looking at right now. If you're sort of familiar with the modular blockchain thesis, Celestia just optimizes for data availability, basically ensuring all actors are aware of the state of the chain. And that allows you to essentially have your own sovereign rollup. And if I were to build something on top of Ethereum as an application, I'm sort of bound by the rules of Ethereum. So I'm limited by what I can do based on what Ethereum can do. With Celestia, I can do whatever I want. I can have my own execution layer. I can choose settlement, wherever I want. And more importantly, I can run my own sovereign blockchain. And we think that's it's a very extremely powerful concept. One other thing that I think is just so fascinating with Celestia is that the ability to run light nodes on your phone. So using an Android, you can't do it on iOS, but Android allows you to, Celestia lets you run light nodes on your Android phone. And to give you an example of where this would be very useful, when you're signing transactions on Ethereum, you're actually not talking to the Ethereum blockchain. You're talking to Alchemy or Infura, and they're talking to the blockchain. So you're using a third party to essentially sign transactions. You're hoping these third parties don't censor you. With Celestia, with these light nodes, you get to directly speak to the blockchain. You have a one-to-one sort of relationship with the blockchain in terms of being able to sign directly to it. And we think for self-sovereign communities and for self-sovereign individuals, we think that's a very important thing.
Absolutely. And thank you for bringing that up. This is something that ETH maxis tend to gloss over, sweep underneath the rug about, which is the fact that there are multiple centralized choke points on Ethereum that make it completely unscalable. And I'm not talking about scalability in terms of throughput and TPS per se, but scalability about the individual being able to autonomously verify transactions directly with the blockchain. You can't do that without Alchemy or Infura because the hardware constraints are so high to actually fully verify a node. That being said, you can't actually run SPV with Ethereum. And if it is the case that you could do like client verification through your phone, which is powerful, that lends itself to IoT applications.
100%. So one thing I really want to mention about Matrix is they've built out sort of infrastructure for pretty much IoT as well. So essentially assume in the future it's going to be machine-to-machine communication all the time, everywhere. And that machine-to-machine communication will need a messaging layer. Messages is just, in its own primitive, the base layer of all communication. And with these light nodes and light clients that are embeddable, you get true IoT functionality. And like that's like the real future, where like all these nodes around you, these devices, you own them with your public-private key, and they're able to send messages on behalf of you or on behalf of others. That's definitely like sort of the utopian future we want.
Is that the utopia future that Helium is trying to get to?
Yeah, so Helium is very cool.
I think so too.
Our goal is to be Helium in the future, but my whole thesis is that this is the node. This is going to have 5G connectivity, even better Bluetooth. It'll have a terabyte of data. It'll have longer life cycle for batteries, and I can use a secure enclave here to sign my transactions. I can use my Face ID for a light form of Sybil resistance. The thing is, like, I want to just get inside the phone. That's why I'm building a chat app. If I'm in the phone, I'm in the node. The one thing, I love Helium. I love it. But they took a sort of harder route with hardware. Operating the world of bits is much harder than the world of atoms. And I really respect them for doing that. Our end goal is essentially, this is the node. And we could sort of become like a Helium-like player if we have all of these devices holding our sort of client-like software.
And when you say that the world of bits is harder than the world of atoms, what do you mean by that?
Oh, my bad. I don't know if you said that right. World of atoms is harder than the world of bits.
Yes. Okay, got it. So manipulating the physical world is harder than the digital world.
You need much more energy.
So with IoT, this actually lends itself to the broader vision of Web3 or decentralized web, which is that we are moving off of SMS as your identity and onto your on-chain identity via your pub key, in which you could have many and in which you could access anonymously or pseudonymously. Would that lend itself to using your key, using your phone now to unlock your car instead of the way that Tesla is implemented right now?
Yeah. So I think the future is sort of multi-factor identity, where multiple sort of parameters give rise to sort of an authenticity score. I think some interesting implementations of these peer-to-peer models is, how do I know like you're human? If my device is close and we've interacted, our Bluetooth can pick each other up saying, oh wow, he was a real person next to me. There's a likely chance that he's a human and not a bot. And those little sort of markers and sort of attestations go a long way to ensuring some level of Sybil. Basically, you have this federated model of reputation on top of these public keys. And yeah, we think that's pretty powerful.
Coming up on time now, so let's wrap up with, are there any announcements you have, big milestones that you're about to hit, anything with timing or call to actions?
So we're launching our beta soon, probably in early March, right after ETH Denver. And unfortunately, right now, you can't log in with Cosmos, primarily because we're waiting for Wallet Connect v2 to ship, which will come with Cosmos, and then we can easily integrate it. But right now, you can log in with Solana and Ethereum. And yeah, we're building out full like Discord-like functionality with messaging on iOS, Android, and web. and we'd be happy to have you join us.
Well, thank you, Ozzy, for coming on the podcast and teaching us about Zoe.